Hi folks, Mr. Wolf here. This statistics lesson is on least square regression. Let's take care of this board problem here. Community College announces that the correlation between college entrance exams, exam grades, and scholastic achievement was found to be negative 1.08. On the basis of this, you would tell the college that the entrance exam is a good predictor of success. The exam is a poor predictor of success. The students who do best on this exam will be poor students. The students at the school are underachievers. Or the college should hire a new statistician. Well, what do you think? Well, it's actually choice E, you guys, because remember, your correlation right here, your correlation R has to be between -1 and +1 inclusively. It can be -1 or +1, but it can't be anything past that. And this is past that, so this guy's bunk. He needs to get out of here. All right, so it's choice E. All right, so least square regression, you guys. So a regression line between two variables x and y in an equation, a line in an equation that it best fits the data. Boy, I got tongue-tied on there. So regression lines, unlike correlations, requires that we have an explanatory variable and a response variable. Okay, equations of least square regression lines, and so we abbreviate them as LSCR for least square regression line, is of this form right here. Okay, this is called y hat. Okay, y hat, which is our prediction y, equals bx plus a. All right, now I don't know if your book writes it like that. I think our book writes it like that, and I think your calculator writes it as a plus bx. So just be aware, you guys, it's just y equals mx plus b from your Algebra 1 class, okay? Where the number in front of the x is your slope, that's the b. And how you calculate your slope is you get your correlation from yesterday's lesson, or the prior lesson, times the standard deviation of y divided by the standard deviation of x. And the y-intercept, which is this a, is you take your average of your y's minus your slope, that's my slope right there, times the average of the x's. Okay, it's not as hard as it looks, you guys, I know you're thinking, ugh, it's really not that hard, especially since we can do it on our calculator. Okay, so notice this is y hat, and y hat is our prediction y. So when you see that little hat right there, it means y hat. It automatically means it's a prediction y. It's not the exact y, it's the predicted y. All right, so let's construct a least square regression line for the example 3.9 on page 153. All right, everything is given to you here. So suppose we have an explanatory and response variable, and we know that the mean of the x's is 17.222. The mean of the y's is 161.111. Standard deviation of x's is 19.696, and of the y's is 33.479. All right, and the correlation is 0.997. Okay, that's a good correlation. Even though we don't know the actual data, we can still construct the equation of this least square regression line and use it to make some predictions. So the slope and the intercept can be calculated as, okay, here's the slope right here. The slope equals r, my correlation, times and everything's here, you guys. R is right here, 0.997. The standard deviation of y is right here, 33.479. And standard deviation of x is 19.696. So let's go ahead and calculate that, you guys. All right, so I get 1.65. All right, now let's get my a, my y-intercept. Okay, a is the average of the y's, which is this, 161.11, 1111, I mean. And then minus b times the average of, remember, b is my slope, so it's this number right here, the 1.695. Times the average of the x's, which is the 17.222. So there it is, all plugged in right there. So it cranks out to 131.920. That's my A. So now it's in the form of y equals mx plus b, but it's actually y hat equals bx plus a. Okay, I think your calculator says a plus bx, I think. So the least square regression line has this equation, you guys, right here. All right, looks like they did the mx over here. So here's my mx plus b right there, okay? Or the way they want you to write it is y equals, I guess it's written over here, a plus bx, okay? I'd rather write it as bx plus a, so it looks more like a mx plus b. All right, so that's my prediction line, you guys. Now you can use that to predict a very accurate x value. And why is it very accurate? All right, think. Why is it very accurate? Because r is really close to 1. When it's close to 1, they're very, very linear points. So when you make a prediction, it's going to be right there on that line right there. Okay, so let's do this on our graphing calculator. Let's clear your lists and clear out any equations that you have in y equals, and we're going to go back to the Sanchez family again. We're going to use this all the time. All right, so we're going to list all the degree days in list 1, so this column and this column here, and all the gas consumptions in list 2. Okay, so go ahead and do that. I'm going to go ahead and pause. Okay, and then you guys pause, and then once you get them in there, let's go to Stat, and then scroll over to Calculate. Hit number 4. It'll say Linear Regression, and it says AX plus B. See, they did do it that way, and your book does it the other way. It's just mx plus b, you guys, okay? And then you're going to get this right here, linear regression, ax plus b. Then you put in list 1, so it's second function number 1, hit your comma. List 2, second function number 2. And then y sub 1, you guys, y sub 1 is in, go to vars, V-A-R-S, scroll over to y vars, and then you'll see y sub 1, y sub 2, y sub 3. So then just hit enter. Okay, and you'll see this y sub 1 appear. Okay, so y sub 1 is in vars and then y vars. All right, and then hit enter again, and you're going to get this right here. Okay, that's a really accurate one. Actually, I don't know how accurate it is because of the R right there. All right. Okay, so there it is right there. That's my equation right there. Okay, so and if you hit graph, go ahead and hit graph. And if you don't get that graph, then go ahead and hit zoom 9, which is zoom stat. It zooms in on the statistics that's in your calculator. And since we said y sub 1, we stored this in y sub 1. So if you go look into y sub 1, that equation is now in there. This equation right here. This equation right here is now in your y sub 1 equation. So it graphed that also. It graphed the line. And look how, that's my best fitted line right there. That's what a least square regression line is a best fitted line. Okay, so the equation of the regression line makes prediction easy now. So just substitute any x value into the equation right here. So if I wanted to predict the gas consumption of 20 degree days, which would be 45 degrees, because remember a degree day is how many degrees it is below 65. And so it's 45 is 20 degrees, so it's a 20 degree below 65. Anyway, plug in 20 right there. Sorry for the long answer right there. And so you find out that their gas consumption is 4.869. And just check the units and make sure your units are appropriate. So go back and see what the units are. Cubic something, I forgot what it was. Okay? All right, and if you're in my stat class, it's a pretty easy one. You're going to find the least square regression line for exercise 3.6 on page 125. Don't forget, I want you to state the mean and standard deviation of both the x and the y and their correlation. Okay, and then use that information to predict that for 1,000,000 power boats. That's with the power boats in, I think, the Mantees in Florida. Alrighty, nice easy lesson for you. Take care.